Good? All good? Yeah. Sweet. Hi. Hello. Hello. Everyone also here. Hi. I'm Yash. I'm hi. I'm part of the DAT project. I recently joined like 6 weeks ago, so I'm probably the newest member on the team. We're like 8 people. Working sort of like all over the planet. There's people in like the US, in Taipei, in like Scandinavia, and I live here. Yeah, so I'm going to talk on something that I've only recently started playing with, which is the peer-to-peer stuff we do. I joined the team to do UI stuff, but I spent 2 weeks in Tokyo learning all about what we do under the hood. And I was the only one that could make it out, so you guys deal with me today. Hypertechnology is the name of the talk. Hypertechnology. Okay, so that is funded by nonprofits, by philanthropists. They give us a bunch of money and we develop technology. The idea behind that is to make science reproducible, to make it so that people in science, they got all these data sets and like all these code stuff, and not a lot of peer review happens. So we try and help out with that by providing tools for scientists. And one of the problems we're tackling right now is moving data sets around, making sure that if you want to reproduce a thing, you probably need the data set that the scientist used, so you need to get that data set across. Say that data set is microscope data, it might be a couple of terabytes, and you need to move it efficiently across the globe, and like, say someone appends to a data set, then you probably don't want to re-download the whole set, but just like the changelog. So that's what we do with several technologies. We kind of like build a little technological cake, one might say. At the top of the thing is a command line tool called DAT, which you can say DAT. I'm in a directory somewhere on my command line. I say DAT this directory, then it will boot up, and it will give me a key. And then I can take this key, and I can like go to some random other directory. So it's now uploading, doing stuff. Make their whatever. This key, and then it will like start downloading this data set. Whoa, hey, my thing disconnected. I don't know why.
We have the same issue with the same database.
Oh wow, interesting. That. And then here, sorry, I got it wrong even. But then it starts downloading the data set. And the command line is a bit borked, but the idea is that you can efficiently move one data set from one place to another. But yeah, that's the super high level thing, just sharing a directory. If you look into the directory, there's a .dat folder. If you tree the .dat folder, it's actually a level DB, and it's got some files in there. It's got some keys in it. Well, do we have keys? We should have keys in there. We're moving keys into there. But yeah, that's the super high level thing, just moving directories around and you don't have to care. But this is built on 2 layers of tech. The first one is called HyperCore, which is super cool. It's peer-to-peer streams. So in Node, I'm not sure if people are Node developers, but this should like hopefully translate. Node, whatever. You can do, you can require FS, and if you want to pipe like standard into or actually, let's do this. If you want to pipe standard in to standard out, you do process.standardin.pipe process.standardout, and now anything that comes from standard in will be piped out to standard out. If you want to replace this with the file system, you can fs.create write stream my file, and now anything that's piped from standard in is piped to a file. Now imagine you could do this on a distributed network. You could take any arbitrary piece of data and pipe it out, and it gives you a key, and you take that key, and anywhere in another thing, you put that key inside of another stream, and then the two start connecting, and all data that's put into this thing is piped out to anyone that has that key. that is what HyperCore does. Code for that looks like this. So this is my, it's a package called Normcore, which is like a no config HyperCore thing. But the idea is, wait, do I have the right one? No, I don't. This is the first one, like that. So you say, let's delete this code. Const feed is Normcore. You just give it a name, hi. And then you say feed.append. You console log the key, log feed a key, the to string hex, and then it gives you a key to console log, and then you append data into the feed. And then this this key that will return here can be used to like get data from anywhere else. So if we run this node in JS, this is all like, by the way, demo driven. I don't have fancy slides. I don't really like fancy slides. You can like get this key. We just appended the word hello into there. And then let's see, we get an outstream. We can do key feed to, let's call this, yeah. So we do node, key is our key. Oh, let's try that one again. Key is our key, and then we do node, what was it? Some file, what do we have here? Oh, we're actually in the whatever directory. Get out of there. Okay, take two. Key is the key we just got, and then we do node out.js, and then we should give it a name, process env key. Ooh, something's going wrong there. Maybe we need to make this one line. Does it work now? Yay! Then we got the whatever we put into the first thing out. So if we run this one again, that should have like hello twice in there now, or not. Anyway, skipping forward. Distributed streams. Yep, that's what HyperCore does. It's actually pretty much like magic. So the way these streams connect is the key it gives you is hashed and put on the BitTorrent DHT. So someone else, it's using HMAC, I believe. So someone else that wants to connect to this thing, you give it a key, it also hashes the key, and that looks for it on the DHT for peers that are connected to that thing. And then that's the way you find each other. So you can't reverse the So if you look at the DHT, you can't find the peers unless you know like the original key. Does that make sense? I hope it makes sense. Yeah. So that's pretty magic, but something we build on top of this is called HyperDrive, which is distributed directories. It isn't necessarily files on the hard drive, but it's the analogy of a directory. So you create a new drive. I'm not going to show the code here right now, but the idea is you create a drive and you append files into the drive, and those files are taken and they're binary diffed to create like optimal chunk sizes. And then we get to like move those chunks around the network. It's all like using gossip. And say you've got a very large file. Am I still making? I'm still making sense. If you've got a very large file, then using moving these chunks around. Actually, let me just phrase this. No, let's not phrase this. Sorry, I'm just slightly getting nervous. I'm like very used to having a microphone here, so I can like hear myself real loudly, and now I'm like hearing all these little sounds, and I'm like, oh God, what's going on? But yeah, HyperDrive. So HyperDrive is the directory analogy. We binary diff all the files in there. We make sure they're optimally chunked. And if you update the file within the directory, say we're compiling a bunch of like C++ code, and we create a binary output, and we like create a bunch of patches for our code, and we like create another binary, then all we will do is get the diff from the two things using ribbon chunking, and like send you the diff, or at least we're working on this. Yeah, go ahead. It sounds like this would be a better Dropbox. It is a better Dropbox. Yeah. Oh, actually, to maybe like take one step back, what we're building all the way under the hood is basically a better BitTorrent. I should start with that. So the problem with BitTorrent right now, I should have started with this. So the problem with BitTorrent right now is you can't do live data. You've got, say, you get one movie file or whatever. You share this movie file and everyone in the network gets it and that's it. But if you like have a directory of pictures and you want to append pictures to that directory as they come out, I don't know, you're traveling or whatever, you can't do that. You need to create a new torrent every single time. That's like very annoying. If you want to do movie streaming where you're like appending frames all the time, you can't do that using BitTorrent. But you do want to use the things BitTorrent is doing. You do want to have like this distributed like network of people talking to people and like reducing latency, and like if we're on the same network, we just share the files with each other. All those properties are like super, super nice. So that is what we're doing using HyperCore, HyperDrive, all those technologies is get those properties and mold it into something that you can use to just share data across a thing. So the moving a directory around, like the dat command, is like pretty convenient to move like one directory around. But all those other things you can like drop down and use whatever low level you want to be in. Go ahead.
So like, if you were filming police speeding up protesters with BitTorrent, then you would have to film it and completely and then upload that whole thing, and by that time the police have stolen your phone. But unless you can live stream the police speeding up protesters, so once they take your phone, you'll stream them taking your phone. So you can do like live. You can create your own live television station.
And they can't take it down. So you can create your own live television station, and they can't command YouTube to take it down because everyone's got the files, if you do it well enough. Yeah. Can I show?
Did
Yeah.
you just say that you still depend on BitTorrent for sharing the key around?
So the question is, do we depend on BitTorrent? The answer is we currently use their DHT to bootstrap our nodes. Because the whole thing is like completely distributed and everyone's hosting it, but we're going to be adding our own DHT as like a secondary way of bootstrapping it. But yeah, you can all, yes. The answer for now is yes. Go ahead.
Do you mean the BitTorrent DHT technology or the actual network?
We rely on the actual network. Yeah, it's just convenient because everyone's running it, so.
Yeah, sure.
Can I show more cool stuff? So my slide said freestyle, which I just did, and then it says demos, and then it says goodbye. But I don't want to say bye quite yet. So let's see if I can find something cool. So my coworker, who's not here, Hypervision, built peer-to-peer television, which is like a cool thing. I live streamed a talk in Tokyo with this thing. Which was like fun. He like presented on this thing right before me, and I was like, cool, I'm presenting on something completely different, but I'm going to use this to live stream my talk. So we got some files here. Oh, there's patches, but we're not going to run them. So we're just going to start it up and pray it works. And it works. I think we could start it twice. So now we say record. Now we got a key here, which is the same key as like with that or whatever. So we got our second thing here. We do npm start. So we're second instance, and then we paste our key here, and then we get our actual video feed. Yeah, it's playing back. Someone else could just take this key and like.
Does that use your webcam?
No, it doesn't use my webcam yet. I think we're adding like microphone and like webcam support at some point. Yeah, it's peer-to-peer television. And like the more people, the fun thing of this thing is the more people are on the network, the faster it becomes. So it's like the inverse of traditional networks where, oh God, there's more people on network, everyone slows down. This is the inverse. More people on network, everyone speeds up. Yeah, so this is peer-to-peer television. We got it working, which is like fun. Well, by we, I mean Matthias. Like I said, I just recently joined. I'm playing around with this stuff. What else have we got? Oh yeah, we got the desktop app, which is kind of broken because I broke it. But I could show it, I guess. Fingers crossed that this will work. Probably not. because I'm breaking it. There you go, see? I broke it. Okay, I won't show off the desktop app. Maybe I can show off the designs. Nah, whatever. We have a desktop app that kind of works like Dropbox. That's the gist of it. But it's my full-time job, so I'm keep breaking it all the time locally. So I can't show it off right now. Yeah, I think that's about it. Better BitTorrent. Yeah, I think that's it. Questions? Yeah. Go ahead.
Okay, I hope you don't have to repeat yourself. I might have missed the beginning, but how's it? That is the structure and hyperdrive, all these things are your products. So is that a company or how's this all?
Okay. So the very quick recap of how that works, which everyone sort of does their own thing, but we've got a structure in how these things work. Lower level, distributed streams. On top of that, distributed directories. On top of that, an opinionated command line tool to move directories around, which creates a local .dat thing. On the side of that, we have, I didn't mention this, but we have a site called .datland, which acts like a GitHub for data sets. So you create a profile and you can upload your data set. We're working on this, which is meant for science data. Say you have a big machine learning data set or whatever, you put it on there and people replicate it. We're working with papers to add links to their papers to hey, I want to download the data set, you get it from there, and we share it. So that's sort of the structure. Does that make sense? Was that an answer? Does that answer your question?
Somewhat. So
Somewhat, okay.
That is not a company, definitely not, so right?
No.
So it's a project, open source project.
Yeah, we're a nonprofit. So, yep, just building stuff.
That sharing, is there a sense to use blockchain?
If we use blockchain?
Yes.
No.
It's similar to internally, it's more close to secure Scala. It uses signatures and hash links, but doesn't use proof of work.
He knows more about the internals than I do, so we're protocol friends. So maybe, so yeah.
Okay, so it uses, so for the video, it uses Merkle tree. So it's like a more complicated way, it's a little bit more complicated than what Secure Scala uses, which is just a linked list, but it uses a sort of tree where you can append to it live, but you can verify any subset. So I can be I want, when you link to someone.
So the users can update the data set, yes?
Only by appending to it. So it makes sense for live television or a live podcast.
Yes.
But I could link to what happened at this offset, these seconds, which on YouTube you can go link to this timestamp, and then it links to 50 seconds in. You can send a link like that, and they can get the thing out and verify that that's really what that's the right thing.
Okay. Yeah. And there is some kind of application for live sites, yes?
Sorry?
There was some kind of application for live sites.
Application for live sites?
Yes.
I'm not quite sure what you mean by that question.
Just because I just misunderstanding. At the beginning, there is a site for science databases.
Yes. That's the base idea. So the base idea is to get big data sets, move those efficiently around, yes, without needing to get the whole data set down all the time, and by making sure you get from close peers. If you just append one value to a data set, don't download the whole new thing, just get the latest values, get the diff.
Yes.
But you could use the DAT protocols for anything where you need to move a big amount of data around efficiently. Live BitTorrent is the best analogy. Any other questions? Well.
How are you going to learn more about the project? I mean, that is really difficult to Google, So.
I'm not on the thing. The thing is not working. Is it? Am I? Oh, I think I'm connecting. I should have mentioned this. I've never done a DAT presentation before. So I guess you're all my guinea pigs. thatproject.org. And if you want to learn more about like the internals, this link. But yeah, basically this should give you the gist of what we do. There's presentations and more on there. Yay. Yeah, thank you very much.
Do you have a white paper?
Oh, working on that. We have one in our GitHub repository, which is up for review. So if you want to read it, you can read it now.
Yeah.
Cool. Thanks a lot.